upgraded high-tech V4 Abrams is much more advanced than the first Abrams tanks produced decades ago. There are limits to how much the existing Abrams platform can be upgraded. A lighter weight, more high-tech tank will allow for greater mobility in the future, including an ability to deploy more quickly, handle extremely rigorous terrain, integrate new weapons, cross bridges inaccessible to current Abrams tanks, and maximize onboard networking along with new size, weight and power configurations. Although initial requirements for the future tank have yet to emerge, Bassett explained that the next generation platform will use advanced sensors and lightweight composite armor materials able to achieve equal or greater protection at much lighter weights. "We will build inside and underbody protection from the ground up," Bassett said. Bassett said certain immediate changes in manufacturing techniques could easily save at least 20% of the weight of a current 72-ton Abrams. The idea is to engineer a tank that is not only much more advanced than the Abrams in terms of sensors, networking technology, force tracking systems, and ability to control nearby drones and vastly increased firepower, but to build a vehicle with open architecture such that it can quickly accommodate new technologies as they emerge. For instance, Bassett pointed out that the Abrams was first fielded with a 105mm cannon, yet built with a mind to potential future upgrades such that it could be configured to fire a 120mm gun. The vehicle needs to have physical adaptability and change and growth ability for alterations as one of its premises, so it can learn things about energy and power and armor. The Army really needs to think about growth as an operational need, Ricky Smith, Deputy Chief of Staff, G9, Training and Doctrine Command, told Scout Warrior in an interview. Smith explained how, for example, Humvees were not built for the growth necessary to respond to the fast-emerging and deadly threat of roadside bombs in Iraq. The new tank will be specifically engineered with additional space for automotive systems, people and ammunition. As computer algorithms rapidly advance to allow for greater levels of autonomy, the Abrams tank will be able to control nearby drones using its own onboard command and control networking, service developers said. Unmanned wingman-type drones could fortify attacking ground forces by firing weapons, testing enemy defenses, carrying supplies or performing forward reconnaissance and reconnaissance missions while manned crews remained back at safer distances. Bassett, and developers with General Dynamics Land Systems, specifically said that this kind of autonomy was already being worked on for current and future tanks. Active protection systems are another instance of emerging technologies which will go on the latest state-of-the-art Abrams tanks and also quite likely be used for the new tank. Using computer algorithms, fire control technology, sensors and an interceptor of some kind, active protection systems are engineered to detect, track and destroy incoming enemy fire in a matter of milliseconds. The Army is currently fast-tracking an effort to explore a number of different APS systems for the Abrams. General Dynamics Land Systems is, as part of the effort, using its own innovation to engineer an APS system which is not a bolt-on type of applique but something integrated more fully into the tank itself, company developers have told Scout Warrior. The use of space in the new vehicle, drawing upon a better allocation of size, weight and electrical power will enable the new tank to accommodate better weapons, be more fuel efficient and provide greater protection to the crew. If you have less volume in the powertrain, you can get down to something with less transportability challenges, he said. If you add additional space to the vehicle, you can take out target sets at greater distances. While advanced Abrams tanks will be using a mobile auxiliary power unit to bring more onboard electrical power to the platform for increased targeting, command and control technologies and weapons support, mobile power is needed to sustain future systems such as laser weapons. The Army cancelled its plan for a future ground combat vehicle, largely for budget reasons. Some of the innovations, technologies and weapons systems are informing this effort to engineer a new tank for the future. Design specs, engineering, weapons and other innovations envisioned for the GCV are now being analyzed for the new tank. In particular, the new tank may use an emerging 30mm cannon weapon plan for the GCV, the ATK-built XM813. The XM813, according to Army developmental papers, is able to fire both armor-piercing rounds and air-burst rounds which detonate in the air in proximity to an enemy and defilade, hiding behind a rock or tree, for example. The computer-controlled and electronically driven weapon can fire up to 200 rounds per minute, uses a dual recoil firing system and a semi-closed bolt firing mode, Army information says. The new tank may quite likely use a futuristic, lightweight 120mm cannon first developed years ago for the Army's now cancelled Future Combat Systems, or FCS. FCS worked on a series of leap-ahead technologies which, in many instances, continue to inform current Army modernization efforts. The FCS program developed next-generation sensors, networking, robots and a series of mobile, high-tech 27-ton manned ground vehicles, or MGVs. The MGVs included a non-line-of-sight artillery variant, reconnaissance and surveillance, infantry, medical and command and control variants, among others. One of the key vehicles in this planned future fleet was the Mounted Combat System, or MCS. The overall MGV effort was cancelled by former Defense Secretary Robert Gates in 2009 because Gates felt that the 27-ton common chassis was not sufficiently survivable enough in a modern IT-filled threat environment. Although the MGVs were engineered with a so-called survivability onion of network sensors and active protection systems to identify and destroy approaching enemy fire at great distances, many critics of FCS felt that the vehicles were not sufficient to withstand a wide range of enemy attacks should incoming fire penetrate sensors or hit targets in the event that the sensor malfunctioned or were jammed. The Army's MCS program developed and test-fired a super lightweight 120mm cannon, called the XM360, able to fire existing and emerging next-generation tank rounds. The lightweight weapon being developed for the MCS was 2 tons, roughly one-half the weight of the existing Abrams 120mm cannon. The MCS was to have had a crew of 2, a .50 caliber machine gun, and a 40mm automatic grenade launcher. In fact, the Army's recent combat vehicle modernization strategy specifically mentions the value of adapting the XM360 for future use. Next-generation large-caliber cannon technology. The XM360 next-generation 120mm tank cannon integrated with the OZ will provide the M1 Abrams a capability to fire the next generation of high-energy and smart tank ammunition at beyond line-of-sight, loss, ranges. The XM360